Today's lesson is on evaluating logarithms. Just to recap one more time what we learned last class, the word logarithm means exponent. And because of this connection, we studied the properties of logarithms from the properties of exponents. There are three properties of exponents, main properties: a to the power 0 equals 1, a to the power 1 equals a to the negative x equals 1 over a to the x. And from here, we derived the properties of log. There are three properties of log. Log with base a of 1 equals 0, which means that the exponent of a to give 1 equals 0, so a to the power 0 equals 1. The next property is log with base a of a to the x equals x, which means that the exponent of a, in order to obtain a to the x, will be x. So a to the power of x equals a to the x. And last one is a to the power log ax equals x. And that's because this exponent in here is known as the log. We must raise this base to obtain this number. So the base a to obtain x. Now today we are going to learn a new formula, and that's the only formula we're learning for today. It is probably one of the most powerful formulas when it comes to operating with logs, and it will definitely change our lives for better. It will simplify the way we use logs. Now, we call this the change of base formula. Now, why do we call this the change of base formula? That is because if we are given a number in logarithmic form, such as log with base a of b, we can rewrite this as log of b divided by log of a, providing that we can split b and a, right? Providing that the bases in each log stay the same. So look at it as a form of division for log a b. Okay? So we're going to practice all these properties in our new formula to simplify a few expressions, log expressions. Example 1. Log with base 4 of 64. What does it equal? Now we're going to try to check and see what we can match this expression with. So we have a base of 4, we have a number in here, so I'm going to think that it looks more like the middle property here. So I'm going to try to rewrite it in that form, meaning that I'm going to try to write 64 as an exponential with a base 4. So 4 to the power of 3 is 64. And remember we said that when these match, right? I simplified to leave us with just 3. Next, log 23, 1. Whenever we see number 1 inside the log, without hesitation, we say that the answer is 0. That's the first property. Next is log 3, 1 over 27. So we're going to try to match this one, the base of this number, to this base in the log. So that would equal log with base 3 of 1 over 27 is 1 over 3 to the power of 3. Or even better, 3 to the power of negative 3. So this will simplify, and we get negative 3. Question D. That's a direct application of this formula here, the last one. So without hesitation, now again, Let's say these two simplify and will leave us with number 9. Last, similar to the previous example, we have log x to the power of p applied to this base. So this base and this one here match. So the answer is simply p. Example 2. We have to read the question carefully because it seems as if example 2 and example 3 are the same question. I've chosen these numbers actually to be the same on purpose. Okay, we're going to try to evaluate these numbers using 2 different ways. That's the reason why. So we're going to start with example 2. Use the base 10, and the base 10, as we've mentioned, is the base we see in the calculator in the change of base formula to determine the value in each expression. So what that means is that if you have log with base a of b, we want to change the base to base 10. So we have the base 10 for the numbers log b and log a. So here we go. That means we have log with base 243, log of 243, sorry, over with base 10 over log with base 10 of number 9. I'm going to use the calculator so that we can practice how to use the calculator in the meantime. So we're going to say log 243, close the brackets, and then that divided by log of 9. So we got the answer 2.5. So 2.5, I'll write it in fraction form, 5 over 2. Next question is log with base 8 of 128. So that would be log of 128 over log of 8. And what did we say the base was? The base was 10 for both. Okay, so again, we're going to use the calculator, log 128 over log of 8. And we got 2.3333. I'm going to go under math in here, and I'm going to ask it to write it in fraction form. And 7 over 3 is the answer. So we're going to say the answer is 7 over 3. The power of the calculator, isn't it? Great. So the next and the last question we have log of 216 over log of 1 over 6, right? Now, we said that it has to be a base 10, and we all know that, or we have mentioned that when we have a base 10, we may or may not want to write it. Won't make a difference. I'm writing it for now, but if we forget, it means that it's still correct. So again, log 216 over log 1 over 6. So here we go, log 216 divided by log of 1 divided by 6. Let's see what we get, negative 3. So the answer is negative 3. In the next question, we're using the exact same log terms, but this time we will evaluate them by using a common base. Now, the common base we used in the example number 2 was 10. Now, in these examples, same examples now, we are going to use a common base that would fit both numbers here. So let's start with the first example. Log 9 to 43 is equal to log. Now I'm thinking of what can be the base of an exponential number that gives 9, or the base of an exponential number that gives 243. So I know that I'm going to write it in change of base formula, so I go log over log. So I would say, well, number 9 is 3 squared, so I'll give it a base 3. Okay, and number 243 can be written as an exponential number with base 3 as well. So I'll write 243 as an exponential number with base 3. That would be 3 to the power of 5. So notice that in this case, according to the log properties, these two 3's, you can say that they simplify, and these two 3's simplify as well. And that will leave us with 5 in the numerator and 2 in the denominator. Same answer as the one when we use base of 10. Now, next question. Again, we have log 8, 128. We cannot write 128 as an exponential number with base 8. So we have to change both bases. So a common base can be 2. So we'll rewrite this. We're going to have log, and log 128, log of 8. And we said that the common base can be number 2 because both 8 and 128 can be expressed as exponentials with base 2. So that equals log with base 2 of 2 to the power 7 over log with base 2 of 2 to the power 3. And notice how, based on the log properties, these two simplify will leave us with 7 over 3. It's kind of a game, isn't it? Alright, so next, you can try it on your own if you wish. Just pause the video. We have log over log. 216 must go here. 1 over 6 goes in here. Now we have to think what base we can afford. Well, if we have 1 over 6, the only base we can afford is the base 6. And for 216, the good news is it can be written as an exponential with base 6, so 6 as well. Now, we're going to say that's log with base 6 of 6 to the power of 3. That would be 216, right? Over log with base 6 of 6 to the power negative 1. So that's the 1 over 6 right here. So we have these to simplify, and the answer is 3 over negative 1, or negative 3. So we kind of discovered a pattern in here, so I wouldn't call it exactly a formula because it's not a formula, but we kind of discovered a pattern here. So when we change the numbers in a log to a common base, then we end up to have answers that are the ratios of the powers. So how can I put that into one equation or formula that describes the pattern? So I'm going to say that if we have log of with base a to the m of a number b to the n, then the answer will be n over m. Okay, so we're moving on to the next examples. So they're getting a bit more complicated, not too complicated. Example number 4. We have log with base 5, third root 25, power 3 over 2. So we need to organize our powers there. What was supposed to happen? So 5. So I'm going to start with number 5 in here. I'll write it as 5 squared. And then I'm going to take care of the power 3 over 2 that is closest to 5. And I am going to give 5 square brackets here and bring it to the power of 3 over 2. And there is one last power I need to take care of. The third root converts to a power as well, and that's the power 1 over 3. So we have log base 5 and 5 to the power of, you have the power of the power of the power, so you multiply them all. So that would be log with base 5 of 5 to the power of, these two simplify, the 3 simplifies this one here. So we end up with 5 to the power of 1 actually. So the answer is 1. Next question. Log 240 base 243, 4th root 729. So in this case, we need to use a change of base formula. Why? Because the bases are not the same like in the previous example where you had one base, you had to make the other the same. Both bases have to change. Here, one of the bases had to change. So we're going to rewrite this as log. I'm going to take care of the base a little later. Just going to write here log over log. That's how much I know for now. And let's think about what exponential numbers can make 243. So we just saw 243, that's 3 to the power of 5. So I'll write that down here. I always start with the easier numbers, right? So, and 729, we know that that's 3 to the power of 6. So it also has the 4th root in here, so that must be also to the power of 1/4. And since we see that both numbers are expressed as exponentials with base 3, then we're going to give a base 3 to both of them. We can choose any base, practically any base in here. It doesn't really matter. But 3 would be the better one here. So it helps us simplify it more easily. So that would be log with base 3 of 3 to the power of 6 over 4, right? Here, 6 over 4 or 3 over 2. Over log with base 3 of 3 over 5 to the power 5. So we're going to say these two will cancel, these two will cancel. And we end up with 3 over 2 divided by 5. So that would equal 3 over 2 times 1 over 5, or 3 over 10. That's the final answer. Next question. 5 log 5, 8 minus 3 log 3, 5. So you see the power and the base, the base and the base in the power match. The base in the exponent with the base in the power means we have 8 minus 5. The answer, 3. Now, we're going to take our knowledge for better use, and we're going to try to solve something a little bit more interesting. Something more interesting. Log with base 5 of x equals 1. That's an equation. Let's because we have an unknown variable in it. So we're going to say in order to find x, we're going to use the meaning or the definition of log. We're going to say that phi, which is the base to this exponent, that's log or exponent, must equal x. So I'm going to say that 5 to the power of x, gosh, worse, sorry. So I'm going to say that 5 to the power of 1 equals x. So that means that x equals 5. So that. Next question, log x equals 35. When we see no base, that means the base must be 10. And then that means that 10, the base 10 to the power of 35 must equal x. I actually wouldn't change this or expand this. That would be a lot of work. But I would just leave it in exponential form. Starts with. Next question, simple, a little bit more fun. We have log with base 3 of x minus 9 equals 4. So here is the base 3, here is the exponent 4. It must equal this thing in the log. So we're going to write 3 to the power of 4 equals x minus 9. Now 3 to the power of 4 is 81. So take negative 9 to the other side. And voila, we're done here. Mission accomplished. Next question is a very simple word problem. It says that the number of mold spores in a petri dish increases by a factor of 10 every week. And if there was only one spore to start with, how long would it take for the population to grow to 500? Now, I'm not sure if you remember the formula from grade 11, the exponent, which is an exponential growth, because it increases, it's a population that increases by a certain factor, right? So we use the equation of an exponential relation, and the equation looks like this. Now, A is always the final amount. I is initial. B is the growth factor. And N is number of periods. It can be number of growth or decay periods. Did I write that correctly? Okay, so let's take a look at what we're given here now. So if it increases by a factor of 10, means that would be our B value. Now, initially there was only one spore. That means that's our initial amount. Now, we want it to arrive at 500 spores. So we want it to become 500, this one. So the only unknown we have here is N. We're going to substitute all the numbers we have. I usually like to write all the information down first. So A is 500, I is 1, B is 10, and we don't know the number of weeks. I'm going to let that be W. So we're going to say that A equals I times B to the power of W for the number of weeks, and 500 equals 1 times 10 to the power of W, and 500 equals 10 to the power of W, where W is the log, or the exponent, same thing, with base 10 of 500. Even better, I can say that W equals log of 500, because when the base is 10, we may or may not want to write it. And in order to find that, I'm going to use a calculator simply by entering the numbers. And 2.7, it looks like it's 2.7 weeks. So, therefore, the population will grow to 2.7 weeks. Will grow to 500 bacteria in 2.7 weeks. Alright, so you see this is your homework, by the way. Please take your time to practice. I haven't selected lots of questions here. Okay, so these are short questions. Numbers 1 to 9, number 11 is one of them. Alright, keep working hard and stay optimistic. Bye for now.